Hello everyone. Today we will be explaining the fourth problem of December 2015 long challenge. In this problem we were given a input string, that is a input image consisting of two characters W and B, and we were supposed to convert the string into entire string consisting of B's, that is any string should be converted to this string. So and for that we were given some more strings which we call filters, and for whenever we apply any filter, if any character in the filter is plus, then that character of this string would get inverse, that is if it is W then we will get uh, B and vice versa. So if you see carefully, then we will notice that this can be easily represented in the binary form. Let's say we have the input string as this. So let's say we take W as 1 and B as 0. So we will get something like this. And the binary equivalent, the decimal equivalent of this binary number would be 682. Now our main task is to convert this number into this number, that is entire zeros, that is from this 682 to 0, and for that we are given with some input options. So let's say we have given this 4 input options. Let's consider the first option. Here we are given with plus minus alternatively. So here instead of plus we are writing 1, and instead of minus we are writing 0. So the binary equivalent would be this, and the decimal equivalent of them would be 682, 640, 42 and 682. Now our main task is to as applying any of this inverts the input string. So this is similar to XOR property, right? So just we are supposed to XOR every input string, every input option with the input photo, and check if it gives 0. If yes, then we have to count plus plus, that is we are supposed to count the total number of options. So total number of combinations in the input option, that is we can apply more than one filters here. So let's take the first example, first input option. Here the value is 682. If we XOR it with this, then we will get 0, right? So count plus plus, we will get count 1. Now let's say we apply this 640 XOR 682. It is not equal to 0, right? So we can't apply this. Let's say this 42, if we XOR it with 682 we won't get answer. Then 682 again, if we XOR it with this we will get 0. So by now we got two options. So count is 2. Now let's have more combinations. There's one combination, right? If we apply this to the 640 and 42 to this, then we will get answer 0, right? Because XOR of this is 682 and XOR of that with 682 will give us 0. So there are many combinations. For every n there are 2 raised to n sub arrays, right? This array A is now consisting of 4 integers, right? And we are supposed to calculate all the sub arrays. There could be one sub array like one the 682, 42, 682, and one of 42, 682, anyone. So this finding of all the sub arrays could be done using bit masking, that is for every n there are 2 raised to n combinations, right? So for n equal to 4 here we will be having 16 combinations. We can bit mask like first number would be 0 0 0 0, that is we are not selecting any one of them. So this is one of the sub arrays of the 16 sub arrays. Then one sub array could be this, that is we are selecting this guy. So if we XOR it with this guy we will get 0, so count plus plus. Then second would be something like this. We are selecting only this guy. So if we XOR it with this, answer is not 0, so count remains same. Now if we XOR this 2, this is same as 3, right? So up to 15 we will get all the combinations 0 to 15. But this method can't be applied here. Why? Because here n could be as large as 10 raised to 5, and this method, make a note that this method can only be applied if n is less than or equal to 20. Why? Because for every n there are 2 raised to n combinations, right? So for n equal to 20 there could be 2 raised to 20 combinations, and roughly 2 raised to 20 is same as 10 raised to 6, and for a time limit of 1 second we can have maximum of 10 raised to 6. So at max we can have 20 points from this approach. Now let's look at the editorial. This problem editorial was really nice, and it helped very much. So let's go through it. So the main catch for this problem was, here even though n is 10 raised to 5, but the total number of input strings, distinct input strings, could be as long as max as 2 raised to 10, that is 1024 strings. Why? Because here for every string is having length as 10, right? So and we are having only 2 characters in it, so it is similar as binary number 0 and 1. So at max we can have 2 raised to 10, that is 1024 combinations. So what about the rest of the n? They are all repeated forms of this. So this was the main catch of the problem. So let's look at the solution for this. Instead of calculating for entire range, that is up to n, we can calculate for up to 2 raised to 10, that is we club all the repeated numbers. Let's say we have a array which consists of C0 to C2 raised to 10 minus 1, and for every index it carries the total number of frequency, that is let's say C2 will be having the total number of times 2 is being repeated here. 2 will be when we have something like minus 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 and last plus minus, so that would be 2, right? So we club all of them, and now we are supposed to calculate from this values, and then we can combine the answer. How? Here we uses a XOR property, that is let's say we have a input string s and we apply another string, that is we are actually dealing with integers, not strings here. So if we have a integer, input integer, if we apply a XOR with another integer, so what we will get is something another integer, let's say s dash. Now if we XOR that s dash with again I, what we will get is the i's will get cancel out and we will get the original answer, right? So so if there are even number of combinations, then the character could be changed. Else if there are odd number of repetitions, then the character could be changed, else it would remain the same, right? So and also for every value of ci there would be 2 raised to ci combinations, right? Either we select that number or no. So and out of that 2 raised to ci minus 1 numbers would be 2 raised to ci minus 1 subsets would be even, and 2 raised to ci minus 1 odd subsets, right? So this would be used later. Now let's go through the dynamic programming approach to calculate answer. This won't be the final answer because we would be applying this what we discussed earlier to the answer which we obtained from this. So let's go through the code. We are scanning the first string, that is the input string, and the copy is made into answer. Now answer is having our initial string which we are supposed to convert to 0 and calculate the total number of ways to convert it. Then we are scanning n, and then we are initializing the frequency would be 0 to 10 raised to 4, right? 10 raised to 3, 2 raised to 10, sorry. So we are initializing it to 0, and then we are scanning every input option, that is all this plus minus, and if it is plus then we are making it 1, else we are making it 0, and then we are finding the value of x, that is the number, and then we are incrementing that frequency. What this tells us is that, let's say we first scan 682, then we there is a array whose index is 682. We increment that value of that array to 1 by 1. Then similarly for 640, then similarly for 42. Now 682 it would become 2, right? Because previously it was 1. We are counting the total number of instances and are stored in this frequency array, where index is the input string and the value is the total number of frequencies. Then let's go through the dynamic programming part. Here we are initializing a DP 2D array. Note that since here the total size of n was reduced to 2 raised to 10, right? So as it is equal to 10 raised to 3 in approximation, we can clearly use a that was a clear hint that we should use a dynamic programming approach by using a 2D which uses a 2D array. So we are initializing this array 2D array to 0, initializing the first cell to 1, then we are going through this for loops. Now what we are actually doing is we are XORing all the values with all other combinations. That is, now in this example we were having distinct numbers as this, right? So we are XORing all these distinct numbers. So for that we are using n square approach, but here since n is less than 2 raised to 10, we can easily solve our problem. So what we are doing is if the frequency is more than 0, that is, let's take this example. Here the frequency array is having indexes from 0 to 2 raised to 10, but only index with 682, 640 and 42 will be having frequency more than 0, right? So if that frequency is more than 0, then only we have to add the previous value of dpij, and along with this dp of I and I XOR j. What this tells us is that we are actually XORing with all the values, that is all the combination, this with this with this, all the possible options. And then else if the frequency is equal to 0, then we are simply copying the previous value. So and then the answer would be the last row 2 raised to 10 comma answer. So up to this, what we got is, let's take the same example. Here we have 682, 640, 42, 682 with frequencies 112, right? But we are not uh, uh, seeing the frequency now for the timing. So let's say we have single frequency values. So in short, we have this array, only this array. Okay, so let's calculate the value for this. So for 6, if we XOR it with this, we will get count as 1. Then second option is XOR these two values and then XOR it with this, so count is 2. So from this part we will get answer as 2, and this is what we have done up till now. This answer is calculating all the single values, no repetitions. Now we will be applying the repetition part. This is simple. What we are actually doing is, here we got answer as 2, right, from this. Now we saw, okay, there is one more repetition of 682. So what we are doing is, total number of extra repetitions, how many total number of extra repetitions are there, we are actually twicing the value. So here since there is one repetition, we will multiply the previous answer by 2 raised to the total number of repetitions. Here total number of repetitions is 1, so 2 raised to 1, so 2 into 2 raised to 1 will get answer as 4. So for that we are doing this, we are multiplying for every I. If frequency is more than 0, then we are multiplying answer with power of 2 comma frequency of I minus 1, and then in the end we are printing the answer.